Um, Hello everyone, good evening. So here we shall solve some more KCET previous year question on the chapter bio molecules. So any doubts if you have in any steps, then please write that in the comments section. We shall obviously clarify them. And also in any other chapter of chemistry, if you have more difficulty, then please mention the name of that chapter also in the comments section so that we can give more priority on it and solve more and more questions on that chapter, which shall be obviously helpful for your exam. And also, please install our Sapiens Education a- a- application where we shall upload some important homework questions based on the previous year KCT exam, which shall be obviously helpful for your exam. So here it is told that the number of disulfide linkage present in insulin are. So it means that we should know the structure of insulin. So the insulin structure is we have glycine, which is linked with cis, cysteine. Then it is again linked with cy- cysteine. So all these. So in insulin, it is a, a kind of a protein m- m- molecule which is formed by the linkage of some a- amino acids by linking some amino acids, and those amino acids, one is glycine. In short, I can we can write it GLY, and CYS, it means that it is cysteine. And so here we have cysteine is linked with another cysteine, and it is linked with ASN means as aspergine, as aspergine. And then here we have some disulfide linkages also. Here this cysteine is having a disulfide linkage with this cysteine, and here we have one more disulfide linkage with another cysteine, and here we have phenanthrene, which is another a- amino acid which is linked with cysteine here. Here we have another cysteine which is linked with this cysteine with another disulfide linkage. And here we have alanine. Alanine is another amino acid. So it is the structure of in insulin. So here we have three dil three disulfide linkages. Three dis three disulfide linkages we have. So option A is the correct answer. Then here it is told that a diabetic person carries a packet of glucose with him always because. So since why the rule is that person, in a diabetic person, the sugar level, the sugar level can suddenly fall, and so an immediate intake of glucose, so an immediate intake of glucose can increase the blood sugar l- level almost instantly, can increase the blood sugar level. Here also we should write blood sugar l- level. So his blood sugar level can increase almost instantly. So hence here it is told option A is glucose increases the blood sugar level slowly, which is wrong. Glucose reduces the blood sugar level, which is wrong. Glucose increases the blood sugar level almost instantaneously, which is correct. So option C is the correct answer. Then here it is told there are 20 naturally occurring amino acids. The maximum number of tripeptides that can be obtained is, so therefore the number of tripeptides maximum number of tripeptides that can be obtained by 20 naturally occurring amino acids is 20 raised to 3, which is 8,000. So option D is the correct answer. Then here it is told the letter D in D glucose signifies, so the full form of D is dextrorotatory. Okay. It is, so here if you use small d or small l, then then this D is called uh, dextrorotatory, and when small l is used, then it is called levorotatory. But here when capital D is used, mm, it signifies uh, it signifies that it is glyceraldehyde, which is a standard configuration, which is a standard configuration at a particular chiral carbon, at a particular chiral carbon, which is according to the rules of sugar chemistry. According to the rules of sugar chemistry. So it is simply a standard configuration at a particular chiral carbon, which is according to which is according to the rules of sugar chemistry. So option D is the correct answer. Then it is told that in alkaline medium, alanine, in alkaline medium, alanine exists predominantly as, so it exists predominantly as a zwitterion. It exists as a zwitterion neutral solution, in neutral solution, and in solution, acidic solution, the COO minus ion, the COO minus ion in z- in the zwitterion, the zwitter ion accepts an H plus ion, accepts a accepts a proton, or I can say H plus ion, to cation, form a cation, and in the alkaline solution, the NH3 plus ion in the zwit, the NH3 plus ion in the zwitterion loses an H plus ion to form an anion. The NH3 plus ion in the deuteran loses a proton, which is H plus, to form an anion, to form an anion. So it means that option, uh, so in alkaline medium, alanine will exist as deuteran. So it will exist as an anion. So it will exist as an anion in the alkaline m- medium. So option A is the correct answer. Then here it is said that alpha maltose consists of. So alpha maltose it consists of two alpha D glucopyranose, alpha D glucopyranose u- units with 1,4 glycosidic linkage, with 1,4 glycosidic linkage. So the alpha D, so now alpha D maltose, it is it is obtained from alpha D glucose. The structure is like this. CH2OH O, we have HOH, we have HOH, OH, H, and here we have HOH. So it will link with, so here it is called alpha D glucose. So it will link, so it will react with another alpha D glucose. CH2OH, H. So here this OH will combine with this hydrogen, and one hydrogen will be, one H2O will be removed to form alpha D maltose. Alpha D maltose will be formed, whose structure is like this. This one is HOH. This one is OH, H. This is H. So here again we have OH, HOH, OH, H, H, CH2OH. So this one is called alpha D maltose. So here we can see that here we have 1 4, so it is 1 2 3 4. So it is also 1 2 1 2 3 4. So here we have 1 4 glycosidic linkage, 1 4 glycosidic linkage, and it has, so it consists of 2 units of alpha D glucopyranose. Alpha D glucopyranose. So it consists of two units of alpha D glucopyranose and one 1,4 glycosidic linkage. So option D is the correct answer. So here it is said that which one of the following does not correctly match with each other. So mm, here silk is not a polyamide, lipase is not an enzyme, and butter is not a fat, but oxytocin. Okay, so sorry, here silk, as we know, silk is a polyamide, lipase is an enzyme, and butter is a fat. And oxytocin, it is actually a hormone. It is a polypeptide hormone. So hence it is not an enzyme. It is not enzyme. So it means that option D does not correctly match with each other. So option D is the correct answer. Then it is said that in an alkaline medium, glycine predominantly exists as. So in alkaline m- m- medium, which means that the pH value is high, pH value is high, the amino acids, the amino acids exist as, amino acid exists as negatively charged particles. It exists as negatively charged particles. Mm, since why? Since the carboxylic acid group, which is COH group, it can donate a proton. Since the carboxylic acid group donates a proton, which is H plus ion. So it can easily donate H plus ion. So it exists as negatively charged particles. It means uh, the glycine, which is an amino acid, uh, as you know, glycine is an amino acid. So its structure is NH2 CH2COOH. So here it will give an H plus ion, then it will form NH2 CH2COO minus ion. So it will exist as negative ion. Since it will give H plus ion, since the pH value of the m- medium is high, so it will exist as an anion. So option B is the correct answer. Then here it is said, okay, then here it is said that sucrose is not reducing sugar, since sucrose is not a reducing sugar, since it is chemically stable. It contains no free aldehyde or keto group adjacent to a CHOH group. It is built up of a fructose unit. It is optically active. So sucrose is not a reducing sugar, since the rule is that Now, sucrose is a carbohydrate since why it contains carbon and it has got OH groups, hydroxyl groups. So it is a carbohydrate. So the rule is that which contain all those carbohydrates which contain the aldehydic group, which is the CHO group or the ketone group or the ketone groups hemiacetal in the hemiacetal or hemiketal form, hemiacetal or hemiketal form, and can reduce can reduce Tollens reagent, can reduce Tollens reagent or Fellings reagent are called as sugars are called as reducing sugars. Now sucrose is a disaccharide. Sucrose is a disaccharide since it it has two monosaccharide units. It has got two monosaccharide units which are linked through their reducing centers. It has two monosaccharide units which are through which are linked through the reducing centers. Now reducing centers, it means, so in sucrose, as we know that the two units monosaccharide units are linked with reducing centers which are either a ketone group or it can be an aldehyde group. So these are called the reducing centers, which are the aldehyde or ketone groups. And since they are linked through reducing center, so the sucrose as a whole, it is non-reducing. It is a non-reducing sugar. Um, so it contains no free aldehyde or ketone group adjacent to a CHOH group. So option B is the correct answer. Then it is said that dialysis can be used to separate dialysis dialysis can be used to separate protein glucose and protein. So option C is the correct answer. Then it is said that glucose when reduced with HI and red phosphorus gives glucose, which is C6H12O6, when it is reduced with HI and red phosphorus at 100 degrees Celsius, then it will form N-hexane, which is C6H14, which is N-hexane it will form. And it will form 2-iodohexane. It will form 2 2-iodohexane. So it can give n-hexane. So option A is the correct answer. Then it is said that the statement that is not correct is aldose and ketose sugars in alkyl medium do not isomerize, which is false. Carbohydrates are optically active, which is true. Like for example, glucose can be optically active. Then pentacetate of glucose does not react with hydroxylamine, which is true. Then mm, lactose has glycosidic linkage in between C4 of glucose and C1 of galactose unit, which is true. So aldose and ketose sugars in alkaline m- medium will isomerize. The rule is that aldose and ketose sugars, if they are kept in alkaline medium, they are kept in alkaline medium, then their uh, isomers are also obtained. Then their isomers are also obtained, which means that then their isomers are also obtained. It means that they will uh, isomerize. They will isomerize. So it means that here it is told they do not isomerize. So it is a wrong statement. So option A is the correct answer. Then here it is said one of the following is an essential amino acid. Now, cysteine is not an essential amino acid. Serine is not an essential amino acid. Then tyrosine is not an essential amino acid, but isoleucine is an essential amino acid. Isoleucine is an essential amino acid. Essential amino acid. So option D is the correct answer. Then here it is told that chelosis and digestive disorders are due to the deficiency of the chelosis and digestive disorders. Chelosis and digestive disorders, they happen due to the deficiency of riboflavin. They happen due to the deficiency of riboflavin, which is a type of of vitamins, which is a type of vitamin. So option D is the correct answer. Then here it is told that adenosine is an example of a nucleoside. Since why the rule is that a nucleoside, it contains uh, two components of nucleic acids. It contains two two components of nucleic acids, which is pentose sugar. It will contain a pentose sugar and a nitrogenous base and a nitrogenous base. And adenosine, in adenos in adenosine, this nitrogenous base is the is called as the adenine. This nitrogenous this nitrogenous base is called the adenine. So it means that an adenosine is a nucleoside. So option B is the correct answer. Then it is told glycogen is, so glycogen, as you know, glycogen is called as an animal starch. Glycogen is called as animal starch since its structure is similar to that of amylopectin. Its structure is similar to amylopectin. Structure is similar to amylopectin. O- So the only difference in between glycogen and amylopectin is that amylopectin contains long chains. It contains long chains of about 20 to 25 glucose units. It contains long chain of about 20 to 25 glucose units, and on the other hand, glycogen has got slightly shorter chains. It has much shorter chains. It has much shorter chains of a- about 10 to 14 glucose units. 10 to 14 glucose units. And the the glycogen is highly branched. And glycogen glycogen has highly branched chains. It has got highly branched chains. So hence we can say that the structure of glycogen is so it is structurally similar to amylopectin, but it is extensively branched. So option B is the correct answer. Then it is said that which of the following gives positive Fehling solutions test. So the rule is that test, Fehling test is given only by Al- aldehydes, only by aldehydes. It means that which has got CHO group, which has got CHO group. Now, as you know that in sucrose we have no free aldehyde group. We have no free aldehyde group. On the other hand, in glucose we have free aldehyde units since it has an open chain structure. Now, glucose has got free aldehyde groups since it has open chain structure. It has got chain structure, open chain structure. So hence option B is the correct answer. So hence, uh, since glucose has got free aldehyde group, so glucose only can give positive Fellings test. It can give positive Fellings test, and sucrose can't give positive Fellings test. So option B is the answer. Then it is said which of the following is correct about hydrogen bonding in DNA. Now in molecule, DNA molecule which is deoxyribonucleic acid. Here, here adenine, adenine which is A, it forms uh, two hydrogen bonds. It forms two hydrogen bonds with thymine and with guanine and with guanine. So adenine forms two hydrogen bonds, one with thymine and one with guanine, which is G, and it forms three hydrogen bonds with cytosine. Uh, okay. Forms, okay, sorry, here adenine forms two hydrogen bonds with thymine and guanine. Guanine forms three hydrogen bonds with cytosine. With cytosine. So A forms hydrogen bond with thymine and guanine forms hydrogen bond with cytosine. So ATGC. So option A is the correct answer. Then here it is said that the glycosidic linkage present in sucrose is between. So now the glycosidic linkage present in sucrose is between. Now, uh, so if we show the structure of sucrose, the structure of sucrose structure is like this. The structure is somewhat like this. H, OH, OH, H, here H, OH, here H, and here we have a glycosidic linkage. OH, H, H, OH, OH, CH2OH, and here CH2OH. So here we have one glycosidic linkage here. So here we have one glucose unit. So this glucose unit is linked with one fructose unit. This one is the glucose unit and this one is the fructose unit, which is linked with the glycosidic linkage. So it is the structure of suc sucrose. So it means we have the first carbon, second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon, and here we have the first carbon, second carbon, third carbon, fourth carbon, fifth carbon, sixth. sixth carbon. Okay. So here it means the glycosidic linkage, as we can see, the glycosidic linkage linkage is present in between the first carbon or C1 of alpha glucose. So it is the alpha glucose unit and it is the beta fructose i- unit. So the glycosidic linkage is present in between C1 of alpha glucose unit and the second carbon, which is C2 of beta fructose unit. So option A is the correct answer. Then here it is said that pick the wrong statement from the following. So here it is told that a deficiency of citrus fruits and green leafy vegetables in food prevents okay consumption of citrus fruits and green leafy vegetables in food prevents scurvy. So as we know, scurvy, it happens due to deficiency of deficiency of vitamin C, which is also called the ascorbic acid. So since vitamin C is present in citrus fruits and green leafy vegetables, so it means that if we have such kind of food, then we can prevent scurvy. So which is a true statement. And then it is told deficiency of vitamin B6, which is pyrox uh, pyridoxine, results in convulsions, which is true. Sources of vitamin B1 are yeast, milk, green vegetables, and cereals, which is true. So option C is a true statement, and in option D it is told re- deficiency of vitamin D causes xerophthalmia, which is false. Since why? The deficiency, the rule is that the deficiency of vitamin A causes xerophthalmia, xerophthalmia, and the deficiency of vitamin D is rickets, and deficiency of vitamin D causes rickets. Rickets means weak bones. The bones will be very weak. Okay. So, hence option D is the wrong statement. So, option D is the correct answer. Then here it is said that hormones are secreted by ductless glands of human body. The iodine containing hormone is now the iodine containing hormone is thyroxine, which is secreted from the thyroid gland, gland, and this thyroxine hormone, it contains iodine. So option D is the correct answer. Then it is told which of the following bases is not present in DNA. So the the bases which are present in DNA, the bases which are present in DNA are adenine, then guanine, thymine, and cytosine only. So it means that it does not contain uracil. So DNA does not contain the base uracil. So it means option D is the correct answer. Then it is told the two forms of D-glucopyranose are. The two forms of D-glucopyranose, its two forms are called as anomers. Its two forms, it has got two forms, and they are called as anomers. So option B is the correct answer. Then it is told the glycosidic l- uh, linkage involved in linking the glucose units in the amylose part of starches. So in the rule is that in the amylose part of starch, in the amylose part of starch, the alpha D glucose units are linked to one another through alpha glycosidic linkage. So the alpha D glucose units are linked to one another, linked to one another through the alpha glycosidic linkage. Alpha glycosidic linkage involving the first carbon of one glucose unit, involving the first carbon of one glucose unit with the fourth carbon, which is C4, of the other glucose unit, the other glucose unit. And here only, so it is an alpha linkage, alpha glycosidic linkage. So it will be a C1 C4 alpha linkage. So option D is the correct answer. Then here it is told that nucleic acids, the nucleotides are joined together by in nucleic acids. So in nucleic acids, like in DNA and in RNA, the nucleotides are joined together by phosphodiester linkage. The nucleotides are joined together by the phosphodiester linkage. Phosphodiester linkage. It means that it has got two ester groups. It has got two ester groups, COR groups, and it has one. It has phosphorus also. So it is the nucleotides are joined by phosphodiester linkage. So option B is the correct answer. Then it is told that which of the following is generally water insoluble. Which of the following is generally water insoluble? Now, vitamin C, it is called ascorbic acid. So, which is water soluble, and amylose is also water soluble, and glycine is also water soluble, which is the glycine is a base pre- uh, pre- which is uh, present in the nucleic acids, a base which is present in nucleic acids like DNA. So all these are water soluble. Only the proteins, the fibrous proteins are not water soluble. They are water insoluble. So it means option A is the correct answer. Then here it is told that the vitamin that helps in clotting of blood is. So that is vitamin K. Vitamin K, it helps in blood clotting. So option D is the correct answer. Then here it is told that hyperthyroidism is caused by the deficiency of. So hyperthyroid, so no, it is hypothyroidism is caused by the deficiency of. So hypothyroidism, it means it is it means it is the low level, it is caused by the low level of secretion of thyroxine. It is caused by the low level of secretion of thyroxine hormone. So the thyroxine hormone, which is present in the thyroid gland, so um, which happens due to the deficiency of thyroxine, which happens due to the deficiency of thyroxine, which contains uh, iodine. The thyroxine hormone, it contains uh, iodine. So due to the deficiency of iodine, the hypothyroidism can be caused. So option B is the correct answer. Then it is told C1C4 glycosidic bond is not found in. So in sucrose, as we saw, it has got C1C2 linkage, glycosidic bond. It means that C1 of alpha glucose units is linked with C2 of beta fructose units in case of sucrose. So hence we have C1C2 glycosidic linkage. So here C1C4 glycosidic bond is not present. And in case of lactose, in case of lactose, starch and maltose, here we have C1C4 glycosidic linkage. So hence option A is the correct answer. Then it is told which of the following vitamins is not stored in adipose tissue. Which of the following vitamins is not stored in adipose tissue? So now the rule is that vitamins A, D, and E are fat soluble. They are fat soluble, and hence they can be stored in the adipose tissue. So A, D, and E, they are soluble. They are soluble in fats, and so they can be stored. So they can be stored in the adipose tissue. So vitamin B6, and vitamin B6 is not fat soluble, is not fat soluble, and it is water soluble, but it is water soluble, and hence it can't be stored in the adipose tissue. Hence, hence the vitamin B6 can't be stored in adipose tissue. So option A is the correct answer. Then it is told RA and DNA are chiral molecules. Their chirality is due to the presence of. So RNA is ribonucleic acid and DNA is deoxyribonucleic acid. So now RNA has got ribose sugar unit, has got ribose sugar, and DNA has got deoxyribose sugar, deoxyribose sugar, and both are chiral. They both the so both these nucleic acids are chiral molecules. They both are chiral molecules, and their chirality is due to the presence of D ribose. So the cause of chirality of RNA, the cause of chirality in RNA is the presence of D ribose in it, and the cause of chirality in DNA, that is D2 deoxyribose sugar. So RNA contains D ribose sugar and DNA contains D2 deoxyribose sugar, and due to the presence of these components only, the chirality is caused. So they contain D sugar components and hence it causes their chirality. So hence option A is the correct answer. Then here it is told the primary structure in nucleic acid. So here we can also say that the in case of RNA, it has got beta D ribose sugar. It has got beta D ribose sugar component whose structure is somewhat like this. H2OH, HOH is OH, no, is HOH, and here we have HOH. So here, as you can see, here we have four chiral centers, four chiral carbons or four chiral centers in beta D ribose sugar, which is present in RNA. And in case of DNA, it contains the beta D2 deoxyribose sugar. It contains beta D2 deoxyribose component, which is whose structure is somewhat like this. This H, and this is OH, H. Here we have HOH, and here we have CH2OH and H. So here also, as you can see here also, here we have three chiral centers. So hence, they both are the cause of chirality in DNA and RNA. And in case of, okay, and here it is said that the primary structure in nucleic acids contains bases as GATGC, the chain which is complement, the chain which is complementary to this chain is, so The rule is that the complementary base pairs are the complementary base pairs in DNA are complementary base pairs in DNA are now adenine, the adenine which is A, adenine is complementary to it is complementary to thymine. It's complementary to thymine which is T, and guanine which is G, that is complementary to cytosine. Cytosine which is C. So A is complementary to T and guanine is complementary to cytosine. So hence it is told that we have a nucleic acid, which contains the the chain. The chain is GATGC and so on. So hence the chain which is complementary to this chain, the chain which is complementary to this chain, that will be now G is complementary to C, A is complementary to T, T is again complementary to A, and G is again complementary to C, C is again complementary to G. So it will be CTACG and so on. So option C is the correct answer. Then here it is said that which institute has approved the emergency use of 2-deoxy D glucose as an additive therapy for COVID-19 patients. So that is the Drug Controller General of in India. Drug Controller, the Drug Controller General of India, Drug Controller General of India has approved. It has approved the use of emergency use of 2-deoxy D glucose as an additive therapy for COVID-19 patients. So option B is the correct answer. Then here it is told that a nucleic acid, whether DNA or RNA, gives on complete hydrolysis two purine bases, two uh, pyrimidine bases, a pentose sugar and a phosphoric acid, nucleotides which are intermediate products in the hydrolysis contain. Now it is told that the nucleic acid DNA or RNA on complete hydrolysis, it means in the presence of H2O, it gives two purine bases. It gives two purine bases and two pyrimidine bases, and sugar, a pentose sugar, and a phosphoric acid. And we have phosphoric acid, which is H3PO4. Then it is said that nucleotides, which are intermediate products in the hydrolysis, nucleotides, which are intermediate products in the hydrolysis contain. So here some intermediate products are also formed, which are some nucleotides, nucleotides. So these um, we have to find which ones are these nucleotides. The first option is purine or pyrimidine base and orthophosphoric acid, purine or pyrimidine base, pentose sugar and orthophosphoric acid, purine or pyrimidine base and pentose sugar, a purine base, a pentose sugar and orthophosphoric acid. Now H3PO4 is called orthophosphoric acid only, orthophosphoric acid. Now the rule is that a nucleotide molecule, it consists of a, a nitrogenous base, contains a nitrogenous base which can be either a purine base or it can be a pyrimidine base also. It can be a pyrimidine base also, and it should contain a phosphate group. Phosphate group, it means that it should contain it can contain orthophosphoric acid, and it should contain a pentose sugar. So hence it should contain a purine or pyrimidine base, a pentose sugar, and and orthophosphoric acid. So option B is the correct answer. So hope all of you have understood the solutions of all these questions on the chapter biomolecules. Still, any doubts if you have, then please write that in the comments. We shall obviously clarify them in the subsequent videos. And also please install our Sapiens Education application, where we shall upload some important previous year questions on every chapter of chemistry, which shall be obviously helpful for your exam. So thank you everyone. Bye.